One thing that we can use our equation rules for and our skills in writing expressions and equations is describing number patterns. Um, so a number pattern is just a set of numbers or objects that has an order to it. And every number in the pattern is called a term. So we want to try finding a pattern and identifying a pattern. So here we have our situation where Daryl is making a pattern for a quilt. The pattern shows 40 squares and every fourth square is blue. How many blue squares are in the pattern? Okay, so what we want to do is we want to count every fourth square. Since it said blue, let's go ahead and make this blue. And there we go, that's blue. Okay, so we have the first one already done, 4. So let's count every four square. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. 1, 2, 3, 4. 1, 2, 3, 4. And so on. We can continue counting every fourth square and marking it blue. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 blue squares. Let's go down to the next part. So which squares are blue? We circled them and there were 10 of them. What patterns did you see in the arrangement of the squares? Well, you should have seen that it just skipped 4 every time and it was kind of staggered. The other pattern that you should have seen is that there's a pattern to the numbers because all of the numbers that we selected were multiples of 4. Okay, if you remember, there's 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So you can see there's this kind of staggered pattern of squares, but then also they're all multiples of 4. Let's look at another one. What if we said that there was a pattern and the rule for the pattern is that we're going to add 5 to each number? And the first number is 5. If I add 5, then we have 10. Keep adding 5, 15, 20, 25, 30, 35. So we have a pattern there. What happens to the digits in the ones place? Well, there's no digit in the, or there's a 5 and then there's a 10, and there's a 5 and there's a 10. So we have alternating between 5 and 0 in the ones place. And if we wanted to describe this pattern with odd and even numbers, we can see that the first, third, fifth, and seventh numbers in the pattern are all odd numbers. The second, fourth, and sixth numbers in the pattern are all even numbers. So that's just a way we can describe some patterns. Well, what if we wanted to make the rules ourselves or identify the rule? Let's suppose we have a pattern and now we want to write the rule. And here's an example of this. We have a server at a restaurant who is setting up tables for a large group. One table has 4 chairs. 2 tables have 8 chairs. 3 tables have 12 chairs. 4 have 16 chairs, and so on. How many chairs are at 5 tables? So let's find out what we need to know. We have one table has 4 chairs. And here's a picture of our table with 4 chairs. So there's 1 times 4. Here's 2 times 4. 3 times 4. And so on. We can record this information in something called an input-output table. And an input-output table looks something like this. We have the input, which is the number of tables that we have, and the output is going to be the number of chairs that we have. So let's just write down what we know. Here's one table with 4 chairs. Here's 2 tables with 8 chairs, 3 tables with 12 chairs, and 4 tables with 16 chairs. And you can see a pattern developing here every time we multiply the input by 4 to get the output. Now, something you need to understand about these input-output tables. The rule that you pick for the first number has to also work for the second, third, fourth, and so on, all the way down. The rule must always work. So we have the rule that every time the number of chairs is 4 times the number of tables. 4 times the number of tables. Let's write a rule. We just need to write an expression. We're going to use T for the number of tables. The rule for the number of chairs is 4 times T. Now let's use the rule and find out how many chairs there are at 5 tables. So the number of chairs at 5 tables is, or if this is T, 5 times 4, because we know there are 4 chairs at every table, and that means that there are 20 chairs at 5 tables. One more, we're going to use a rule to find an expression. So here we have input of 2, output of 5. Input of 4, output of 7. Input of 6, output of 9. And input of 8, output of 11. What is in common between these inputs and outputs? What rule can we use? Well, 2 plus 3 is 5. 4 plus 3 is 7. 6 plus 3 is 9. And 8 plus 3 is 11. So we see that the rule is that the output is always 3 more than the input. 3 more for the input. So we're going to create a variable b for the input, and the output c is b plus 3. And we can fill out a table the same way. Here's a new rule. The output is n divided by 2. And here's a table with the inputs 2, 4, 6, 8, and 10. So if the output is n divided by 2 and the input is 2, then the output is 1. Here we have input of 4. 4 divided by 2, output is 2. Here's 6. 6 divided by 2 is 3. 8 divided by 2 is 4. And 10 divided by 2 is 5. So you see we can fill out the input and the output tables with the rule, or we can use the completed tables to develop a rule and write an expression, either way. Also, you'll notice that there are 2 different ways of writing the table. If it's written this way vertically, you'll see the input on the left, output on the right. If it's written horizontally like this, you'll see the input on the top and the output on the bottom. They always look one of these 2 ways. So just remember those placements of the input and output. We'll do some practice problems in class tomorrow. Work on your spiral reviews tonight. We'll see you tomorrow morning.